Cool, thank you so much. Good morning, everyone. Cool, yeah, so my name's Harry. The talk I'm doing this morning is called CSS for Software Engineers for CSS Developers. Bit of an odd kind of recursive title. Basically, what we're going to be looking at is how we can write CSS as front-end developers from the point of view of a software engineer, so applying traditional software engineering paradigms and principles so that our CSS is better quality for us as CSS developers again. So kind of taking a different context to actually write our CSS so that when we're building UIs, building front end, our CSS is a little nicer. So who is a front end developer? Oh, nearly all of us. Who's a full stack developer? Oh, cool. So who is a software engineer? Anyone just pure back end kind of? Oh, well, a bit of everything. Well, hopefully everyone ends up happy. So yes, we will be looking at some sort of the details of some software engineering principles and paradigms, design patterns. We'll dive into some specifics. But before then, I want to start with a really kind of loose history lesson. Very, very loose history lesson. A history lesson starts with these two. This is actually my mum and dad on their wedding day in 1984. I've got no idea what my mother was thinking. And I also realized halfway through giving this talk a few months ago, my dad looks like the Unabomber. If anyone knows the Unabomber, like the serial killer, my dad, I've got some questions as to where my dad was in the 60s. So yeah, but my mum and dad, really important to me for obvious reasons. They're my parents, but they also provide me with an oddly specific professional benchmark because they were both born in 1959. And 1959, as well as being the birth year of my parents, is also widely regarded as being the birth year of the first modern programming language. It's called the first modern programming language purely because it's the first language that actually used English data structures it actually looked like English language. It wasn't just ones and zeros and machine code. It was the first language that actually resembled English. And knowing that the first programming language is the same age as my parents gives me a really handy kind of baseline. When I think about how old modern computing is, it's the exact same age as my mum and dad. So that gives me a real personal, helpful sort of guideline, a timeline, to think about the work that's been done by software engineers before me. It was developed by a woman called Grace Hopper. Has anyone heard of Grace Hopper before? Okay, Grace Hopper, absolute badass. If you haven't heard of her, I implore you, please do some research, look her up. She was an incredibly important individual in sort of the founding of modern computer science. She did a lot of work for the US Navy. Very, very clever woman, very important in any kind of modern programming context. So she developed Flowmatic, which is the most American-sounding name for anything I've ever heard, between 1955 and 59. So it took quite a long time, of course it did. But by 1959, she'd released kind of the first version of Flowmatic. If anyone's ever seen any archival footage on YouTube of Grace Hopper teaching, you probably get the impression she's got a very can-do, no-nonsense attitude. And nothing sums that up for me better than this excerpt from the Wikipedia page. Basically, her managers didn't think it was possible. They didn't think it was feasible to actually build an English-like data language. Instead of being disheartened by that, instead of abandoning any attempts, she went and did it anyway. She just did it, and it worked. And it led to things like COBOL and Fortran were heavily influenced by her work on Flowmatic. So yeah, again, this timeline, this very personal timeline of mine, basically 1959, Flowmatic and my parents were born. 1990, I came along. 1996, my sister, who looks a bit like Winston Churchill, she's got no idea that slide is in this talk. So she better not find out either. And CSS. So the point I'm trying to make here is that the difference between my parents and my little sister is the exact same as the difference between the first programming language and CSS. That's a huge amount of time. That's 37 years. The amount my parents managed to achieve in 37 years, they were born, they sort of educated, they met each other, fell in love, so they claim, married, started a family, all this stuff. That's just what two people managed to do in 37 years. As a front-end developer, I look at that 37 years of time as being an amazingly rich period that lots of sort of founding programmers did a lot of sort of intensive research. They solved problems that never even existed before. It's a huge, rich chunk of our professional history that we should look into just to basically steal things from. I spent a lot of my career looking at traditional computer science. I'm not a programmer, I can't program, but I look at traditional computer science principles that have been around for far longer than many of us have, and I just kind of steal those for CSS, and that's what this talk is going to be about. Looking at this real rich period of our professional history, taking some of it and applying it either directly or indirectly to CSS. The reason I say indirectly, you'll find that a lot of the principles we're about to look at need to be kind of shoehorned and sort of formed a bit to fit into the CSS world, but they do, to an extent, still work. So the first principle I'd like to look at is dry and or the single source of truth. So who's heard of the dry principle? Cool, don't repeat yourself, right? It's a fairly simple rule. Who's heard of the single source of truth? Okay, slightly fewer people. Now, the single source of truth for me is a more philosophical backdrop to dry. So we do dry, and that gives us a single source of truth. So we'll look at the subtle difference between those. Basically, dry states that every single piece of knowledge must have a single, unambiguous, authoritative representation within a system. Basically, don't write the same thing twice. There's a really important word on this slide, which I rather inconveniently didn't highlight. That's the word knowledge. Right, so we'll look at the confusions around dry in a few slides' time, but basically, we don't want to repeat knowledge. Repeating strings in a system, repeating the same characters a few times, that's fine. But if it's knowledge, if it's got important, actual, valuable information, those are the things we don't want to repeat. Those are the things we want to have a single source of truth. So a lot of people take dry to a real extreme where they think that the same string mustn't appear any more than once in a project. It's more about getting rid of repetition of valuable key information. Yeah, so every discrete piece of information should only occur once. You shouldn't need to make the same changes several times. Has anyone ever inherited a project? I'm talking mainly a CSS project, but I guess any project, where you make a change to something and it doesn't take effect, and you can't work out why, and it turns out it's because, oh right, yeah, need to change it here as well. Right, that's basically a problem with dry. One key thing I'd like to point out is that dry isn't like a performance principle, it's mainly a maintenance principle. So dry helps you maintain code. It leads to good quality code, but its primary sort of reason for being is just to make it easier to maintain and look after code bases. If you repeat yourself, it increases cognitive overhead. You have to remember that, oh right, I've got to change this in 3 places. There's nothing worse than having to memorize oddities and subtleties with a code base. It should just be simple to dive in and get working. So the reason we need to focus on drying out code is just so that we are more productive and it's a nicer environment in which we are working. Real simple example then, in CSS world, I'm sure we've all seen CSS like this, just some helper classes for nudging around kind of spacing units. We're using the value of 12 pixels here, and all these values are the same, presumably because this is our baseline grid, or this 12 pixels basically has some importance. Now this is the key thing we need to realize when we're talking about dry. It's this importance. These are all 12 pixels for a reason. It's not coincidental. These are all 12 pixels for the exact same reason. So it's important to dry things like this out, and the simplest way to do that would be to use a preprocessor, stick that in a variable. This is super simple. This is just how we would simply dry out a bit of CSS. We've now achieved a single source of truth, but by drying this out, we have achieved a single source of truth. That variable, $unit, becomes the single source of truth within this admittedly very small system. Slightly more complex example in CSS world would be something like this. So we've got 2 declarations here that need to exist side by side. Whenever we use this font, we have to declare this font weight. So these are thematically related. The declarations are thematically related, but the rule sets are not, right? So the fact that this pair appears side by side, that's kind of information. But the fact we've got pagination, a button, and a page title, that's kind of coincidental. They aren't actually, as rule sets, they're not related. So the way that I would recommend drying this out would be to just use an argumentless mixin. Now we're told that argumentless mixins are a bad thing. Who's heard that before? Argumentless mixins are bad news? Okay, well, it's kind of a sort of an anti-pattern now. That's kind of bad advice, but a lot of people in the CSS world used to say that an argumentless mixin, because it just spits out the same thing over and over again, it just bloats your CSS. Dry isn't about performance, dry is about maintainability. So using an argumentless mixin is like a sassy copy and paste, just gives us this, but it gives us the exact same output. This is the kind of point I'm trying to make. It generates the exact same amount of output, so we end up with just as much repetition. The key here is we haven't repeated ourselves. So the dry principle is don't repeat yourself. It's not don't repeat anything, it's do not repeat yourself. So we can generate repetition quite safely, that's fine. And this leads to the single source of truth, right? We've got the single source of truth now by moving something to one unambiguous initial kind of declaration, and then that gets repeated wherever. So yeah, I see this as a more philosophical take on dry. Single source of truth just gives us a lot more confidence. It means we can make changes much more safely. If we know we can change something in one place and it'll propagate throughout the project, that's just a nice, safe, and sort of convenient way of working. Okay, so the confusion with dry. Dry, as I've said, quite ironic that I've repeated this several times. Dry is all about maintenance. It's not about performance. So if we've got Repetition in production, I don't mind that at all. It's all about saving our repetition in source code. We don't want to type the same thing too many times. So it's not about avoiding repetition completely, it's about avoiding repeating ourselves. We don't want to create any more work. I wrote an article, a quite lengthy article, on when to use mixins or when to use extends in Sass. And basically what it all boiled down to was, if something's repeated 50 times, I don't care, as long as you haven't written it 50 times. Dry, don't worry about performance for now, think about maintainability. Another bit of confusion then. The font weight bold thing is repeated here 3 times, but it's purely coincidental. There are actually CSS libraries out there. There's one called Dry CSS, which aims to never have the same declaration appear more than once in a project. This repetition is purely coincidental. We don't need to dry this out. There's no thematic information here. Font weight bold just happens to need to be in there 3 times. To dry this out, to store this in a mixin would be inappropriate because this isn't key information. So a lot of people take dry way too far and try and avoid repeating absolutely every occurrence of any string ever in a project. That's just going to go the opposite way, and it's going to make things even harder to maintain. So you need to find that sweet spot. So if it's purely coincidental, don't dry it out. Favor repetition over the wrong abstraction. Yeah, so here's another thing. When you start trying to dry out things that are purely coincidentally repeated, you create really awkward relationships on your code base. So if you're using extends in Sass to kind of extend, okay, well, these have got the shared trait, so we'll extend that, and these have got shared traits, so we'll extend that back to the same place. All of a sudden, you've got all this these list of selectors that don't have anything to do with each other, but they all have this same common point in the CSS now. So by drying things out too far, you can start to create really awkward relationships in your project, makes it harder to understand. This is a huge problem with drying out things too much. The last line here is like a real nice soundbite I try and keep in mind. Repetition is better than the wrong abstraction. I would actually rather change something 3 times and have to debug a complex layer of abstractions that kind of obscure that from me. So yeah, starting off with a relatively simple one, the principle of dry. Okay, the single source of truth, who's heard of this one? The single responsibility principle, who's heard of this one? Okay, cool. This is actually a really simple principle, but it's probably the most bang for your buck. It's probably the one principle in this entire slide deck that will give you the most mileage. It's really useful for scaling projects, for recycling things, for reusing things, and for making things very easy to deal with. Now, the single responsibility principle, well, it says all of this. Basically, what it's really trying to say is everything should do one job only. It should do that job very, very well. So we shouldn't focus on making things that are too complex. We should get big monolithic things and break them down into smaller parts. By doing this, we take big tasks, big monoliths, and we make them much easier to understand. Instead of looking at a big, this builds a sidebar, we can look at, well, here we've got a button, that's one thing. Here we've got a heading, that's another thing. We can just separate things into tiny, tiny component parts and then put them together into quite complex composites. There's a surprisingly good real-world analogy for this. Subway, the sandwich restaurant, at a stretch. So when you go to Subway, you don't necessarily order a sandwich because you get presented with all the ingredients. What Subway are doing is they're applying the single responsibility principle to eating, to dining, to sandwiches. Instead of offering you a monolithic sandwich, which should be the name of my new band, they offer you the ingredients to put that sandwich together yourself. It gives you a lot more choice and freedom and flexibility. Subway, for me, is the epitome of the single responsibility principle. Instead of offering you a monolithic thing, they give you the small pieces to make it yourself. So by breaking things down into the smallest possible part, we can get that monolith back, but we get it back through composition rather than inheritance, another principle you may be familiar with. It helps you separate your concerns. It means you can focus on one thing without having to worry about the next. And it gives you incredible opportunity and flexibility. By breaking complex bits of CSS down into tiny, tiny pieces we can put back together, we get much more flexibility. The way this impacts Subway is that you can actually make 6,442,450,944 different sandwiches at Subway. And they all taste terrible. But that's actually true, right? That URL at the bottom there, someone's actually done the workings out for this. It does take into consideration having like a carrot sandwich, but that does count. But you can get 6.4 billion different sandwiches just by using the single responsibility principle and applying that to dining. To further labor the point, let's look at a monolithic sandwich. So this is a monolith. The only way we could modify this is either by duplicating it, giving it another ID, by attaching a class, so maybe #sandwich.vegetarian. So we'd have to use inheritance to actually modify or extend this bit of code. Yeah, it's a monolith, difficult to change, hard to swap things. We can't really do much with this. It doesn't give us much mileage. By simply swapping this for a series of classes, by breaking these down to tiny, tiny responsibilities, we can build that exact same sandwich in the DOM, and we got the exact same result, but with much greater flexibility and much more scope for reuse. Because if we make a salad, we've got lettuce exists completely on its own. It doesn't have to live inside the context of sandwich anymore. This is composition over inheritance. This is the single responsibility principle. Now, the actual implementation of this, I prefer classes in the markup. A lot of people don't like that. The implementation is up to you. But what this means is, I don't really like tomato. Tomato makes bread go soggy. Don't want it in my sandwich. I get rid of it. Not a problem. I don't have to change the concept of sandwich because I just work with the ingredients. But basically, if you're writing CSS that other people in your team are likely to use, if you're writing essentially an internal open source like style guide or UI toolkit, give developers the ingredients and let them make their own sandwiches. To use a slightly more realistic example, we see CSS like this all the time. Button login, right? I see this on a daily basis. First problem with this for me is it's called button login, so it can only ever log people in, so it's kind of a monolith. It's only got one job. The other problem is it's got a mixture of responsibilities. We've got base responsibilities, we've got structural, that gives it its sizing, and we've got 2 cosmetic responsibilities. This one class is responsible for 3 things right now. Simple solution is identifying these responsibilities and breaking them out into individual smaller classes. That's much better. We can start to combine these. We can build that exact same button again, but it could be for logging in, it could be uploading a file, it could be adding a user, adding a friend. This gives us much greater composition. And we can extend that as far as we need to. We can create a suite of different classes that we can compose in the DOM and get the exact same results. Next principle, the separation of concerns. Who's heard of the separation of concerns? Oh, brilliant. So the separation of concerns, when I was researching this talk, I actually learned more about this than I thought I knew. It turns out the separation of concerns isn't necessarily about writing good code. It's not about code quality first and foremost. Again, it's a maintenance principle. The actual definition that you can find on Wikipedia for the sort of separation of concerns, it's really eloquent. It's really, really nice. I'm not going to read that out to you because there's too much of it, and that's like the short version. But what the separation of concerns trains us to do is, can I focus on one aspect of my project without having to even think about the other part? The example cited on Wikipedia is, can I think about the syntax of a program without having to worry about the functionality? Then the next day, can I think about the performance of a program without having to think about its syntax? It just allows you to think in sort of sandboxed, compartmentalized ways. It means you don't have to worry about the effects of an unrelated thing. You can always work fairly confidently. So each thing responsible for itself and nothing more. You can study features in isolation. This means that when you're debugging the color of a button, you don't have to worry about it breaking some layout. It's quite simple in CSS. There are certain things we can do, like real simple things to follow. Only bind CSS onto CSS-based classes. So if you've got a JavaScript class, like a JS hyphen, don't apply any styling to that. Don't write selectors that have HTML elements in them. You know, doing something like header, nav, ul, lia. The problem with a selector like that is it just describes the DOM. We can't change our HTML without risking breaking our styling. That violates the separation of concerns. Don't bind CSS onto data attributes. Data attributes, that's your data layer. It's nothing to do with styling. You shouldn't sort of make the data layer responsible for look and feel. And don't bind JS onto CSS classes. Always use a JS hyphen class for any behavior stuff. These are just really simple tips we can use so that we don't have to worry about breaking our JavaScript whilst we're refactoring our styles. In a little more detail then, the top one, right? Using ARIA roles as CSS styling hooks. People do this quite frequently. Completely violates the separation of concerns. The accessibility of my document should not be responsible for the visual appearance of that document. They're completely separate things. I shouldn't change the accessibility and risk damaging the style of a page. I should be able to worry about those things completely independently. Second one, header, nav, ul, lia. Who's seen a selector like this before? Who's written a selector like this before? Yep, we all have. The problem with this is we cannot change the semantics of our document without breaking its appearance. We've tied the two together, we've coupled them very closely. That's just not good. We don't want to do that. We want to be able to change the semantics of a document and have it look exactly the same. Separating our concerns means we don't have to worry about styling when we're changing semantics. The third one, who even remembers this? You can separate like the young from the old. Yeah, the reason we invented CSS was to get rid of this. We used to put our styling in our content layer. It means we can't copy and paste our content to another place without taking styling with it. It was horrendously inaccessible, really hard to maintain, and it was a complete violation of the separation of concerns. This is why we invented CSS. Final one, fairly simple. Yeah, we're binding JavaScript onto a CSS class here. I don't want to refactor my CSS and risk breaking some behavior. So just swapping out for a JS-nav is what we should be doing. So this top example, right? So as responsible front-end developers, I presume we all write our HTML first, get the semantics correct, make sure the content gets into the DOM, and then we tackle styling it. So we might end up with something like this. And we're like, well, we've got this hook in there already. I might as well use that for styling. And we start to write some CSS that looks a bit like this. I'm not saying we do this, but certain people have done. Basically, I'm not blaming you, right? It's not your fault. But this is horrible. We're loading our CSS with DOM information. We've gone all the way from writing our sort of styles in line to now writing our HTML in our styles. We've just gone completely the opposite side of the spectrum here. What we should actually do, what the HTML should look like, is more like this. And I know what you're thinking. It's quite a departure from the previous one. But to do this properly, this is what we need to do. To separate our concerns, we need to write HTML that looks a little more like this. The reason for that is the first thing we think about is our semantic concern, right? The first thing we decide is what semantics will this part of the page have. Once I've made that decision is done, I can move on to my next task. My next concern is, okay, what is the accessibility of this part of the document? It happens to be a nav element, but we don't care about that at this point. That could be a div. What we're doing is we're separating our concerns. Then we move on to the next concern, which is stylistic. What does this actually want to look like? Regardless of the semantics or the accessibility information about this part of the DOM, our concern now is just how it looks. And then finally, behavioral concerns. There are some really good examples of the separation of concerns, of violations and sort of keeping to. Grid systems, and when I say grid system, I mean like div class equals col6. A lot of people dislike those because they're in-semantic and they kind of bloat your HTML, but what they do provide us is a very good separation of concerns. We've completely divorced our layout from our content. We've got completely fluid components that can sit wherever they want. Whenever we're editing those components, we don't have to worry about whether the page fits together properly. I don't want to change the padding on my nav and find out that it breaks my layout. So having extra sort of grid layout in your DOM completely separates your concerns. Quite a hot topic at the moment is writing CSS in JS. That actually breaks the separation of concerns. The reason we invented CSS is to get it out of our HTML, and now people are moving it back into JavaScript. It's like we don't learn our lesson. We don't want to have to change our JavaScript architecture, and then, we don't want to change our JavaScript architecture and then have to change our CSS architecture as well. We should keep them as separate as possible. A guy called Keith J. Grant put it much better than I can. If in 14 months you find a new Vue library or framework you want to try out, you're out of luck. You'll have to invest a lot of time pulling styles back out of JavaScript modules and into style sheets again. We shouldn't couple, our styles shouldn't depend on our choice of Vue library or sort of JavaScript library. They should always remain as separate as possible. How we sort of couple those in the DOM is up to us, but we should always try and keep each technology in its own kind of place. Immutability, who's heard of this one? This is quite popular at the moment. Okay, immutability, very popular in kind of functional programming and the JavaScript community at the moment. Immutability deals with mutations. An immutable object is an object whose state cannot be changed after it's been created. So that means a mutable object is an object that can be mutated. It's an object that can have its state changed after it's been created. Immutable objects provide us with a lot of confidence. If I know that something always has one job, I can be confident about how it will behave at any given time. Also makes things very predictable. If I know how something will behave, it means I can drop it anywhere, and I don't have to worry about side effects, negative outcomes, anything like that, which therefore helps with debugging. And again, it reduces this cognitive overhead. We don't have to remember subtle caveats and differences when, oh, well, actually, for buttons in the sidebar, it does this, right? That's a mutation. If we have a selector that says a button when in the sidebar, that's mutating how the CSS behaves. Common example of this, if you use a grid system, an inferior grid system, you might see something like this. Col6 width 50%. We've got a 12-column grid, column 6, 50%. But then on a small screen, col6, we type, don't be a grid item anymore, just be 100% width. That's a mutation because col6 has been mutated. It exists twice. It's either 50% or 100%, depending on how we view it. It's kind of Schrödinger-y like that. The state of col6 changes depending on how and when we view it. So this is really nasty, right? It happens all the time in CSS. Responsive design leads to mutations by design. We can't really avoid that. There are certain things we can do to mitigate this actual example. But unfortunately, mutations are really common in CSS. To fix that actual specific example, I just do this. Just stick an @sm on the end, or whatever your breakpoint is. I've written this technique up. It's basically just any stateful kind of like breakpointy or media classes. It's only col6 at small. So either col6 or col6 at small. It means we've got a completely different class. We've got no mutations. Col6 is always one thing. Because col6 at small is a completely different class, it never actually mutates. It just exists completely separately. That at small could be a utility for hiding something at print, perhaps. So it just avoids the mutation, and it just gives you a second class to provide the different state with. Slightly more common example. Take this sort of snippet of HTML CSS. The more kind of astute among you may have realized there's a specificity mismatch here. Subcontent H2 has a higher specificity than text center, which means that text center down here actually will be aligned left. That's very confusing. That's a mutation. What's happened is text center has been overridden. So it's got two states. It's either going to be text left everywhere else, text center everywhere else, or in this context, it will get mutated and forced to be text line left. So that's, again, a mutation caused by specificity mismatches and subtree collisions. Again, this is really easy to fix, though, right? That example there, very, very simple to fix. Stick an important on it. You laugh, I'm actually serious. This is the only time you should use important, is on utility classes. Never use important in anger. But if you use it preemptively on a utility class, u-text-center, we only ever want that to be text-align center. It makes sense to put an important on that. We don't ever want anything to override the behavior of a utility class. Text center should never be text-align left. So the only time I want to see anyone using an important is on utility classes to force immutable state. We don't want a utility class to ever be mutated. Another example of mutations in CSS. I've got a button, but when it's inside a promo area, we just want to increase the size of it a little bit. We could write a selector like promo button. Problem with that is we've got one class, which is button, but two potential outcomes because that promo is like a caveat now. It's a condition. It's a mutation. We're saying like, a button will normally be this, but if it's in here, it will now be this. Again, the fix for this, really simple, just introduce a new class. Instead of saying the button went in here, just say, well, we've got a completely new type of state, and neither of them ever get mutated. So avoid nesting selectors. Nesting selectors lead to mutations. Basically, it gives you kind of the subject and all the caveats. Every time you nest something, it's basically a mutation of, oh, well, it's this, but it's now got a new state or condition in which it lives. So yeah, stick important on utility classes, avoid nesting, and use responsive suffixes or BEM modifiers to produce these different states. Don't provide different states by mutation, provide it by extension. So the nesting and qualifying selectors like a.button or .promo space .button, these are sort of qualified or nested selectors. They are what cause mutations, which brings me nicely onto the next principle, which is cyclomatic complexity. Who's heard of this? Okay, so it's not technically a principle. It's a form of static analysis, but it can be applied relatively well to CSS. Cyclomatic complexity is basically counting the paths through a decision tree. If you've got a function, and it's got if this, do that, if this, if this, if this, if this, every if in there is a count toward cyclomatic complexity. And the higher the complexity, the higher the cyclomatic complexity, the worse the situation. Obviously, we want to reduce complexity. The more ifs means the more different states we have. That's probably going to imply mutations. There's actually like an equation for working out cyclomatic complexity, but I have no idea what it means. Basically, we're looking at the amount of ifs and elses in any kind of source code. Now, that's easy for programming. That's easy for like actual logic. But the more I looked at it, the more I realized that we can actually apply this to CSS. You know, it takes a bit of creative treatment, but we can apply the concept of cyclomatic complexity to our selectors. And that is by looking at how much they're nested. If we see a selector like this, again, we've probably all seen something like this before. This has a really high cyclomatic complexity because what this selector is actually doing is saying, well, if there's a div with a class of main, and if there's a section with a class of content, and if there's an H1 with an A inside it with a span inside that, then do this. We're asking the browser all these questions. There's not really a performance hit of this. It's not like that's not what worries me. What worries me is that we're just making very complex selectors for no real good reason. The problem is we started off with a very wide subject. We asked the browser, is there a span? And 9 times out of 10, that's going to be a yes. We start with a very, very broad subject. Because that subject captured so much of the DOM, we had to introduce all these conditions to narrow that down. What we'd done is we captured way too much of the view, and then we said, oh, okay, but only if it's in this, and if that's in that, and there's this class here, and that class has to be inside this. That's cyclomatic complexity in CSS, and the higher the complexity, the worse we're doing. The solution to this is just start off with a better subject. Yeah, if that span was just changing the color of some text, make a class called text highlight. The cyclomatic complexity of this is as low as you can get. Just one question, is there this in the DOM? If the answer is no, then the browser does nothing. If the answer is yes, it just applies some color. We start off with a nice, sort of very well-scoped subject. Then we can reduce our complexity because we don't have to ask the browser all these other questions. That again leads to a lack of mutation, so this is very immutable. So cyclomatic complexity in CSS is basically how complex are our selectors, how many if statements are there in there. The deeply nested or qualified selectors, just bad news. For a few reasons, they increase specificity, they reduce portability, and now they increase cyclomatic complexity. Yeah, reduce your cyclomatic complexity just by using more appropriate selectors. Just start with the correct subject. Instead of asking the browser a very ambiguous question like, is there a span? Just say, can you find this class, yes or no? This is a real project that some friends of mine built a few years ago. They know that I use this slide. Basically, this was a preprocessor. A preprocessor did this. Remember preprocessor came out and everyone was like, oh, you can nest things, it's so cool. Their style sheet basically started with an opening div hash body and a closing brace, and everything was like all the way down. So it led to selectors like this. Really fragile. The cyclomatic complexity here is 12. There are 12 parts to this selector, 12 chances for something to go wrong. If that div changes to the main element, everything's broken. Yeah, nothing works anymore. Just to pull this out into a more easy-to-read slide, break it onto 2 lines. That selector just styled a button. The complexity there is absolutely enormous, and unfortunately, it turns out that worked just as well. If you delete everything else, the button still rendered correctly, its hover states were fine, everything was fine. So reduce your cyclomatic complexity. It's usually wasted bytes, it increases specificity, and it just makes things way harder to deal with. The other thing as well is, I can delete that, because I'm a person, I can verify that selector still works. Even the most intelligent minifiers will never touch your selectors, so any verbosity in selectors is completely dead weight. We can't get rid of that with tooling. So just keep your selectors as short as possible. Aim for like 1 class, 2 classes nested maximum. Okay, the open-close principle. Who's heard of this? The open-close principle is absolutely fantastic. It's terribly named because half the important information is missing from it. The open-close principle actually states that things should be open for extension but closed for modification. This means if we need to make a change to anything, we can do that going forward. We can always extend things. Think of like semantic versioning. If you need to change something in a release because it was broken, you can't just change what 1.0 was. You have to release 1.1. So that's basically the open-close principle. You always have to work forwards. So yeah, software entities should be open for extension but closed for modification. This basically tells us do not go back and change things once people are relying on them. Imagine tomorrow you go to work and you build a button, you design a button, you build it, and you push that to the shared repository, and everyone's relying on that button now. In June, you come back to working on it, it's like, oh, I don't like this button actually, this button seems a bit big, I'm going to reduce the padding, and you do that, and you push that. You've got like 5 months of people relying on that work that you potentially have a knock-on effect through. So going back and changing something that's already been released is a very, very risky thing to do. The open-close principle helps us avoid those knock-on effects. It's very, very, very handy if you're joining a legacy project or you're on a project that's already kind of legacy. Really good if you work in teams. It means that you don't accidentally regress other people's work. Anyone work in a team where CSS regressions seem quite frequent? You write something and it seems to... Not a single hand. I'm coming to work with you guys. That genuinely surprises me. But if you ever get that situation where you write some new styles and it breaks something in a completely unrelated part of the site, or vice versa, someone writes some new styles and it breaks something of yours, the open-close principle helps us to avoid this. So yeah, this is the key bit, right? So you're not allowed to go back and change things unless it was actually a bug. The only time you can go back and change something is if it's actually fundamentally incorrect. So So yeah, once completed, the implementation of a class could only be modified to correct errors. So let's say that the buttons were genuinely wrong. Let's say that the designer sent you the wrong hex color and it was genuinely the wrong color of button. Then you would go back to that button CSS file and you would modify the error. Then you'd have to go through and check every instance to just double check everything's fine. So the only time we can go back and change something is if it was actually a bug. If someone decides that we want that button a bit bigger, you cannot go back and do that at the source. It's too risky. What you would do is you have to provide a new flag, a new feature like button dash dash large to say, right, we can have bigger buttons now. The legacy is still safe. We're not going to regress anything by accident, but we can opt into the new version always moving forwards, like the Semver analogy or Git history. You should never sort of rewrite Git history because anyone who's relying on that is just going to get those regressions, they're going to get problems. It's going to cause a lot of work for other people. So yeah, a button with a padding of 1em and 2em. Once we've pushed that, once that's out there, once people are relying on this, it's too risky to change it. We shouldn't change this. One option would be to do .promo.button, but we should know why we wouldn't do that because that's a mutation and it increases cyclomatic complexity. Bad idea. We're still modifying base button there. We're still actually editing the button class just via a different means, via a different condition. Real simple, same as before, just add a new class. This is a very safe way to introduce changes to a code base. It's kind of like a double layer of security. If you've ever seen like an Indiana Jones film or like some kind of Mission Impossible film where like there need to be two people either side of the room who puts like a key in a lock at the same time, and unless there are two of them, nothing will open. Or like if you want to nuke a country, two people have to lift up a button and press the button at the same time. That's what the open-close principle is. The open-close principle in CSS basically tells us add a new class to the CSS and add one to the markup. The previous example of .promo.button means that I can write some CSS, save it, refresh the browser, a change will happen. It's a one-sided change. The open-close principle tells me that I need to create a class in the CSS. If I save that, refresh the browser, nothing will happen. What I have to do is open the view, put a class in there, save that, then refresh the browser, then something happens. So this open-close principle gives us that two layers of security. It gives us the two people either side of the room. It gives us a way of not regressing things. We have to opt into any change we introduce. So that's why it's so good at safeguarding when we work with legacy. A really important principle to remember if you work in a team or on a kind of like a legacy environment. Orthogonality. Who's heard of this one? Orthogonality. Oh, cool, like a couple of us. Orthogonality is fairly new to me as well. Orthogonality basically says that we should be able to use features of a programming language in arbitrary combinations and still get consistent output. So orthogonality in CSS is actually quite simple, really. We should be able to write CSS that we can combine and sort of compose UI components in any order, and it should still work. What this basically means is we're reducing our interdependence. If we can include our buttons before our header and it still works, it means that those two files obviously didn't need to know about each other. This means we've got a nicely decoupled system. It means we've got interdependence. It means we've separated our concerns. It means we've got single responsibilities. So orthogonality is kind of the hallmark of a well-built system. A really good litmus test for whether your CSS is orthogonal or not is, can I reorder my imports? If you can do this, like, so you've got all your components in your sort of toolkit on your site. If you can reorder them, save it, compile, and the browser still, or the web page still looks correct, you've probably got very orthogonal CSS. None of those files actually relied on any of the other ones. That's a really good litmus test. It's not a guarantee, but it's just a good way of working out that, oh, cool, like I can use these features in arbitrary combinations, still get consistent results. If the answer to this is yes, you can do that. You've probably got a very well-built modular UI. Your CSS is also probably very modular. You've got very few dependencies. So orthogonal CSS is really, really nice to work with. Another good test of orthogonality is, can you nest things arbitrarily? Can I put this inside this with no kind of adverse side effects? Well-scoped selectors, so basically things that don't have a high cyclomatic complexity, can really help produce orthogonal CSS. I've got an example here. I really hope this example makes sense as a screenshot, but what you can hopefully see here is we've got collisions. We've got a selector called promo, and we've got a selector called promo h3. But promo h3 can actually leak down into the DOM, and it's actually styling this testimonial title class. You want to see what's happened there? We've got a subtree collision. This promo h3 selector is too greedy. It goes way down the DOM tree, and it's caught something completely unrelated. This has led to a regression. So we actually created a style that's, well, not necessarily a regression, but definitely a collision, right? Styling's affected something it shouldn't have done. Therefore, it's got a mutation. Testimonial title now has caveats. It's either testimonial title or testimonial title when inside this promo. And because it's got like that kind of dependence that we don't actually want on promo, it means it isn't orthogonal. So hopefully you can see here that badly written selectors capture too much of the DOM. This is called a subtree collision. A greedy selector like promo h3 has just gone way down the DOM tree and caught something completely unrelated. Best way to fix that would be to not use a complex nested selector. By swapping that out for promo title and testimonial title, we've got orthogonality now. We don't get that subtree collision. Promo h3 doesn't exist, therefore it can't capture something further down the DOM tree. So orthogonal CSS can be produced just by writing much, much better quality selectors. And it looks like that's me wrapping up, actually. Got some time for questions, kind of whiz through those. But thank you very much for listening. Yeah, I've got a bit of time for questions if anyone has any. Mm-hmm. Yeah. Yeah. So yeah, that's a really interesting approach. I've seen people implement that, like you said, because media queries do just lead to this very complex mutation. So yeah, sticking a new class on the body element, depending on the state of the thing, it will work. I think media queries will be around. I don't think we'll get rid of them anytime soon. But you'd have to, the problem with, or the potential problem with the class thing is you might still get mutations if you were to nest things and say, well, button large in this. So button large could still exist. Yeah, it could be large in a small context, but large in a large context. So we still would get some nesting there, which would increase the cyclomatic complexity and therefore mutations. But I think that's something we'll just have to deal with. Obviously, we want everything to be immutable, but I don't actually think it's going to be possible, and certainly not for CSS. We can get the low-hanging fruit by not writing nested selectors. And I think with things like responsive, whichever way we tackle it, we will have to accept there's going to be some level of mutation. Your buttons might all grow a certain size across breakpoints. Whether you do that via a class or a media query is probably going to create mutation. But yeah, it's certainly an interesting approach, and it's one that I've seriously considered using myself. My usual approach with problems like this, though, is just to avoid them completely. So I would try and just say, look, can we change as little as possible across breakpoints, just to minimize the amount of work we have to do? That's just me being a lazy developer, I guess. Cool. Any other questions on anything at all? Sure. Mm-hmm. Yeah, so CSS modules are basically, unique strings for class names so we don't get collisions. That's completely fine if collisions are your problem, but it still doesn't get around the cascade. So we can't really fully encapsulate things. So I would rather go for a half solution. I'd rather look at like web components. If I was concerned about collisions and the cascade, I'd be looking to use web components instead. I think CSS modules make sense in terms of collision, so you don't get two of the same class. But for full, complete encapsulation, I would prefer a solution. I'd prefer to use something like web components. But yeah, I think that CSS modules does solve an actual genuine problem. I was working with a client recently who wanted to embed their sort of widgets on a client or a user's site, and they want to expose certain classes so the user could theme it themselves. What they wanted to do is use something like CSS modules to leave their classes completely obfuscated, but have some permanent classes that are always like user-facing. So I think for stuff like that, it can be really important, and they were looking to use CSS modules to provide that functionality. So I guess it depends on what you actually need. But for complete encapsulation, to actually get around the problem of the leaky cascade, I would look for, web components.
The subway principle you mentioned, when implementing the subway principle, doesn't it sort of collide with the similar responsibility? Because we put parts of this down back into
Yeah, so this is a really good question. So basically, by going for a class-heavy approach, we are kind of going toward putting style information back in the DOM. There is like a sliding scale. I think our industry's got a huge problem with overcorrection. So we started off like this side of the pendulum, all our styles were in our HTML, and the pendulum swung this way, and we had the web standards movement where it was like, don't put any IDs or classes anywhere inside your HTML because you should be able to do it without. Then we started swinging back, and now I think we're finding a middle ground where we've got judicious use of classes to say, right, well, okay, we need to put some information as a hook, but as long as we're not writing button red or inline styles, I think using classes is the safest middle ground right now. So yeah, we are moving some style information from our CSS to our HTML, but I think the sensible middle ground is something like using more abstract names. So as long as we're not actually writing inline styles, I think that judicious use of classes is probably the safest. That middle of that pendulum, basically. I think, are we getting kicked out?
The thing is, I have to be back for this session because we have the next talk in about 3 minutes.
3 minutes?
Yeah.
Well, our times are different, but yeah, cool.
Yeah, from a different country, aren't you? But hey,
Thank you all.
Amazing discussion. If you like, I'm sure you can catch Harry outside.
Yeah, definitely, definitely.
You single-handedly invented CSS engineering, I think. So great job, amazing stuff, and
Cool.
thanks for being here.
Thank you.